Good night. Good evening, I guess I should say. We're going to talk about solving. We've been doing a lot of factoring of polynomial expressions. We're actually going to be doing some solving of polynomial equations here. And the only thing that's actually nothing is new because we've already factored polynomials and we've already applied the zero product property. So we'll refresh the zero product property relatively quickly and then just get into a couple of examples. It is, like I said, a couple of old things put together to make something new, so to speak. But in order to solve polynomial equations, we simply need to write the equations in standard form, make sure they're equal to 0. That is really, really important. Factor the polynomial accordingly. It could be by grouping. It could be a sum or difference of cubes. It could be a quadratic. It could be in quadratic form. It could be a difference of perfect squares, a perfect square trinomial. All those things are still possible at this point. Just some things to some things to think about. As it says, these will not always be the case, but they're good places to start with factoring. For even degrees, try to factor the polynomials the same way you would quadratics, going way back to chapter 5. For odd degrees, most likely we're going to need to factor by grouping. And then obviously don't forget those special cases when there's only two terms. Those will either be a difference or sum of cubes or a difference of perfect squares. Let's get into an example here. If we look at this, we actually need to make sure that's set equal to 0. 9x to the 4th plus 5x squared minus 4. We're looking here. There's 3 terms. We have an even degree. I'm going to check and see if I can make this just quadratic form. I need factors of 9 and factors of 4 that when we somehow multiply them together, we get 5x squared. So I think I'm going to do 9x, and I think I'm going to do 4 here. I think I'm going to do x and 1. This will be plus, this will be minus. If we check this, I get positive 9x. There's big thing. Make sure those are squared. I get positive 9x squared, and here I get negative 4x squared. Those do combine to get 5x squared, so we're in good shape there. So now as we solve these, we use the zero product property. 9x squared minus 4 equals 0, or x squared plus 1 equals 0. And now we solve these two. Add 4 to both sides. 9x squared equals 4. Divide by 9. I get x squared equals 4/9. At this point, we would need to take the square root of both sides. Just something to remember we can do. That leaves us with x is equal to plus or minus 2/3. Square root of 4 is 2. The square root of 9 is 3. Now, obviously, when we take a square root, we have to remember the plus or minus. So there's 2 solutions. Subtract 1 from both sides. We get x squared equals negative 1. Again, we'll need to take the square root of both sides. We get x is equal to plus or minus I. Those are our possible answers. As you can see, nothing's new. Really, we put a couple of newer things together and made something here, factored a polynomial, and then applied the zero product property. As we take a look at this example, we are not equal to 0. That's the first thing I'm looking at. And then I'm also looking at 4 terms with an odd degree. So I'm thinking right now that once I get it set equal to 0, I'm going to need to factor by grouping. I have 3x cubed plus 7x squared minus 12x minus 28 equals 0. If I look at my first 2 terms and my second 2 terms, the first 2 terms, all they have in common are x squared. So I get 3x plus 7 in that case. Next set, I can factor out a negative 4. That'll give me positive 3x plus 7 equals 0. And that's good because we end up with the same thing in both sets of parentheses. So what we do now is we factor out the 3x plus 7. Factor that out there. And then we also have x squared minus 4. Remember, those come from right here. That makes the other set of parentheses. Now, this is one of those problems we've seen where we can also now factor the x squared minus 4. We have 3x plus 7 times x minus 2 times x plus 2 equals 0. And we're ready to solve. 3x plus 7 equals 0, or x minus 2 equals 0, or x plus 2 equals 0. We get x is equal to negative 7/3, x is equal to 2, x is equal to negative 2. Those are our 3 possible solutions to this polynomial equation. To refresh, we first had to set it equal to 0. We then had 4 terms with an odd degree, so we thought grouping, which did work out in this case, and we kept factoring until we had our 3 real solutions. In our last example here, 54x cubed equals negative 2. Again, we need to first set it equal to 0. I get 54x cubed plus 2 equals 0. As I'm looking here, we have a common factor on the left side. That's 2. I factor that out. I get 27x cubed plus 1 equals 0. Sum of cubes, I get 2 times the quantity, 3x plus 1 times the quantity, 9x squared, minus 3x plus 1, all equal to 0. We set these equal to 0 now. 2 equals 0. Obviously, we don't have to worry about that. 3x plus 1 equals 0, or 9x squared minus 3x plus 1 equals 0. This one's easy. We get x equals negative 1/3. That last one, 9x squared minus 3x plus 1, we're going to need to apply the quadratic formula. Here's my a, b, and c. So we apply that. It's the opposite of b, so we're going to have positive 3 plus or minus the square root of b squared minus 4ac, 4 times 9 times 1, all over 2a. So we have 3 plus or minus the square root. I get 9 minus 36. That's negative 25 all over 18. This is 3 plus or minus 5i all over 18. Final answer there. Final answer. Again, we may need to apply the quadratic formula. That's especially going to be the case when we have a sum or difference of cubes. That's it for tonight. We'll catch up with a couple examples tomorrow, and we'll go from there.